Hello, welcome back everyone. In this video we're going to look at how to handle or treat command line arguments. So on the right hand side we have a C code where the C code essentially is telling us we're going to pass in some command line arguments A and B, and in the end we're going to multiply A and B together, and then we're going to print A and B out as a string. Okay, so sometimes we want to write our program in this form in the command line, and then we do some computation with it, or we work on it. Maybe if it's a form of a string, we work on it and then we print something back out. Okay, so essentially what this is going to do is, this whole C program is going to do is going to take A and B, multiply them. Firstly it's going to convert them to integers, and then multiply them, and then we convert the product value back into a string. We've already seen this in the integer handling, I think part 2 or part 1, yeah. Okay, and then we print it back to the screen, and then we add a new line character to it so it looks nice. So this is what I mean. So let me save this and then we try compiling this. And so we have command line arguments, we have 4 and 5, so the answer should be 20. That's all there is to it. So let's look back at the C code, and then finally we can look at Nasm code. So on the right hand side we have the Nasm code, and it follows the same structure. But essentially what I would like to talk about in the Nasm is essentially how to deal with the command line argument. So Nasm has the following structure. So when we call the program and we want to know the number of arguments passed in there, we're going to have to check in the RSP register. And in the RSP register, we're going to have 3. Okay, and if it's not 3, it means we're going to exit. So essentially what I mean is this. So we have our normal setup, and RSP is going to contain a number of command line arguments, and that's going to be we're going to pass that into R8. And why 3? 3 because we're going to include the program name. So the program name is going to be the first one, A is going to be the second one, and then this is going to be the third one. Okay, so we're going to pass in RSP into R8, and we're going to check whether RSP is essentially equal to 3. And if it's not equal to 3, we're going to print out an error message, which is essentially this one, and then we're going to jump to exit failure. That's we're going to exit with a code of with 1, just like the way it says in the C side. Okay, and if it's essentially if it's equal to 3, then we're going to prepare the command line arguments, because when passed in there, they are actually strings and not integers, so we're going to have to convert them into integers. We've already seen this in the integer handling part 1, and so to be able to pass in the command line arguments into an integer, we need to know their locations. And once again, when I bring this up, we see that RSP plus 8 is going to refer to the program name, and then RSP plus 16 is going to be that of A, the position of A. The RSP plus 24 is going to be that of B, the position of B. And then we see that if we have subsequent command line arguments, it's just going to be factors of the differences are going to be 8. That's like multiples of 8. Okay, so for example, should we add maybe another one over here, then it's going to be 24 plus 8, which is 32, and then that's going to be its reference. Okay, so as I said, A is going to be in the RSP plus 16, and because ATOA is a C function, to be able to use the C functions, remember we have to do an extend ATOA up above. Okay, so to be able to use the C functions, we've already seen that RDI is going to take the first argument, so we need to pass our value into RDI, and then after calling the C function, which is A2I or TOA, its result is going to be in the RAX, and then we're going to place it into our A value. Okay, so essentially the A string is this. We're going to pass it into RDI, then we're going to call A2I, then its value we're going to place into A, and A has already been reserved up here. We reserved a 64-bit integer size for A. Likewise for B, RSP plus 24, we're going to pass it into RDI. Then we're going to call A to I, and then the result is going to be placed in RAX. So we pass the value back into B. Okay. And so essentially, with this uninitialized values, we see that we've already written them here. And we've now looked at how to convert them into integers. So now we're going to look at how we're going to do the product. One would think that perhaps after converting them, it's easier to just do, say, I multiply C, maybe A and B. Although essentially it should work, but this is not going to work because memory instructions are not allowed. Okay, so what we're going to do over here is, once again, we're going to pass the values of A and B back into registers and use those registers as intermediary registers. So A is now going to be, we're going to pass it back into a copy into R8, and then B also we're going to pass a copy of it into R9. We do our multiplication where this line essentially is the same as follows: R8 equals R8 times R9. Okay, and so the product of R8 times R9, which is essentially A times B, is going to be placed back into R8. Okay, and then we're going to move the product back into C. Okay, so after this, we are essentially going to print out a new line where the new line character is 10. So I'm going to print out a new line, and RDX is 1 because it's only 1 byte. We're going to print out a new line to the standard out, and then we go to exit success with an exit error code of 0. Okay, and then the failure, as we've already seen, the case where the args is not equal to 3, we have 1. Okay, so this is essentially what I wanted to show you guys. Once more, let me bring it up. So I'm saying that RSP is going to contain the number of command line arguments, which in our case is going to be 3 because we have 1, 2, 3. And to reference the program name itself is going to be RSP plus 8, but we do not need that. Our program is essentially A times B, so we're going to reference RSP plus 16 and then RSP plus 24. We do the product, we convert them into integers, we do the product, and then we print it back out to the screen. And remember that when we're trying to print it back out into the screen, I'm using this. The print num is a macro I wrote myself, and the output is essentially we're reserving 20 bytes. Okay, it's a macro I wrote myself in the include macros.inc. We've already seen this in the integer handling part 2. Okay, so let me quickly run this code. And then 4 and 5 should also give us 20. So that's essentially it. Let's do 4 and 4, 16. Yeah. So this one I wanted to show you guys today. Bye.